All right, we are recording.
Right. Well, welcome everybody to our monthly Ask an Expert session. My name is Steve. I will be your expert this month talking about platform designers. So welcome everybody to our session. Just a brief little bit about myself. I have now worked for Altera and now Intel for almost 17 years, and I've been in the training group for 15 of those years, teaching all sorts of different topics. Only that's what's listed here is basically a subset of the areas that I cover. I also do power. It mentions external high-speed memory, external memory, all sorts of different topics. With platform designer and embedded system design, one of my main focus areas. And you can see my email address right there. So why are you here at our monthly Ask an Expert session? Well, if you've been to one of these before, welcome back. If you've never been to an Ask an Expert session, why are you here? Well, maybe you're just starting to learn about Platform Designer, and you have some questions that have been in the back of your mind that you haven't really had anybody to ask. Or maybe you're familiar with the tool, you started creating a system design in the tool, and you're seeing something in the tool that you don't understand, something you're trying to do you don't understand. I don't know how to do what I think I need to do. You want to build a system, but something is not quite right. You're seeing some type of message or something, or you're just stuck. It's okay. People get stuck. The tools are complicated. There's a lot involved. That's why we have these sessions. You also might have come to hear about some of the new cool features that have been added to Platform Designer. Every release, almost, we have a number of new features, and I'm going to highlight a couple of those new features in a little bit. And finally, you still call the tool QSys. It hasn't been called QSys for about 5 years now, but some folks still call it that, even because the file name is .qsys still, but it's not called QSys anymore. So. If everybody could also mute their mics, that would be great until you have a question. Then I can answer your questions. So thank you. I just wanted to highlight where to get information from the Intel website. There is a lot to the Intel website, and things have changed and moved around a little bit recently. So just to highlight real quick where you're going to want to go. You're not going to want to go to support. You're going to want to go to developers. Under developers, this is where you can download Quartus, you can read documentation, and also get access to other Intel FPGA training resources. So under resources and documentation, let me turn my little laser here. Right here, you can get resources and information about Quartus. And then under Learn, you have to scroll down a little bit, and then you get to the Intel FPGA technical training section and exploring the catalog. Now, the next couple of slides, I have a number of resources that I wanted to highlight before we get into it. Steve is going, it's my moderators, that's confusing. We have two Steves, Steve E and Steve S. But Steve E is going to be putting these links in the chat at some point. So don't worry about not being able to click these things right now. They will be available in the chat before the end of the meeting. So as far as instructor-led training is concerned, I just taught this, and I think I'm teaching it next week as well, is our Introduction to Platform Designer training. This is our main training, instructor-led training, that goes through all the basics of using the tool, from building a system to actually creating custom components that you can add to a system. I'm actually in the process, just some inside baseball here, of it's currently a full day 8-hour class that virtually we present over 2 days, but we're going to break up the class into 2 4.5-hour training classes. So if you're only interested in building systems, we're going to have a training with hands-on lab practice for that, and a second day, if you want to come to it, or just come to that one, about creating custom components and integrating them into your system design. So I'm actually working on this as we speak, and that's going to be available, I think, about in a month or two. And then online trainings, we have tons of online training. You can just sit and listen to me for more if you really want to. An intro to Platform Designer, creating system designs with Platform Designer, And these 3 online trainings really are everything you need to get started if you're not familiar with the tool at all. Excuse me. And then beyond the basics, we have additional online trainings go into detail on creating custom components for use in Platform Designer, and then my 4-part advanced system design with Platform Designer series that covers simulation, using System Console for debugging a system design, system optimization, and making use of the hierarchical features to build hierarchical system designs in Platform Designer. And finally, I have a dedicated online training all about Platform Designer in the Pro edition. This one's a little older right now. I probably need to update that one. But there are some unique differences that are covered in that for using Platform Designer in the Pro edition that that training goes into detail on. And finally, of course, the documentation. So you definitely want to download one of the user guides, either the Lite and Standard Edition user guide or the Pro Edition user guide, depending on what version of Quartus you are using. And finally, if you want some videos, of course, we got lots of videos. Our quick videos playlist from the Intel FPGA YouTube page has a number of short videos that you can watch about all sorts of different topics. I think there's some Platform Designer ones mixed in there. You can check those out. So the ground rules for our Ask an Expert session here. Any question you can think of is fair game. Lay it on me. And Steve's going to tell you in a moment how to do that over the phone or in the chat. If it is a detailed design specific question about something that you are working on, I'll try my best based on what you tell me. We don't really have time in this session to for you to share your screen and me take a look at what you're working on. So I'll try to figure it out as much as I can um, from your description. If not, we can follow up with you later, and you can let Steve E know that that you want to do a follow up. But if it's more complicated, then I would point you to your local FAE for detailed help with your project. Okay. So Steve, you wanted to go over how people can ask questions?
Yes, thank you. So I'm Steve E, your moderator. I'll be monitoring the chat window so that Steve doesn't have to look at the chat window while he's discussing things about Platform Designer. So if you'd like to ask by voice, by all means, that's perfectly reasonable. Just go ahead and unmute yourself. Go ahead and ask the question. And when you're done, just please mute yourself again so we can minimize any background noise. If you prefer not voice, chat window is perfectly fine as well. So either option is good, and it's how we do these in the Ask Expert session. All right, thank you.
Hey, thanks, Steve. So before I go into new features, which I can sprinkle throughout the hour, did we have any questions yet that we wanted to start off with?
So there were a couple of questions that came in during the registration process. Maybe we could start off with a couple of those.
Sure.
One question is, can I connect conduits together or to each other? So conduits, special type of interface, non-standard interface. Anyway, that's what the question's about.
Okay, it's a good starting question. So, excuse me. So, a conduit, for those that are not aware of it, is an interface that is made up of signals in your system design that do not make up one of the standard interfaces supported in Platform Designer, which include the Avalon streaming and memory map protocols, as well as the ARM AMBA AXI protocols. So, for example, here I've got a system design that connects to buttons and switches on my board. And if I look at that, I can actually go to the block symbol diagram here and see the individual signals that make up that conduit. So this is a custom component I made myself, but you can also, a number of off-the-shelf IP include conduits as well. And one of the questions that people ask, like Steve said, is how do you connect conduits together? Or can you connect conduits together? And the answer is you can do it, but in most cases you are not going to do it. The reason being is that conduits are usually custom mixes of signals and you don't normally connect them to each other. But if you didn't need to connect them to each other and they had the same signals but in opposite directions so that they would connect together, you would just click two dots. So one dot here and one dot here would connect these two conduits together if I, for some reason, really wanted to do that. Now, the thing is, with conduits, there isn't the same type of interface checking that's done with the interfaces that that are standard, like Avalon or AXI. So you have to make sure that the signals on both sides are the same names and in opposite directions to make sure that they will connect. Otherwise, you're going to run into errors and issues when you try to compile your design. In most cases, conduits are simply exported like this to be used outside of the system. So yeah, conduits.
I think okay, thank you, Steve. And again, these questions I'm pulling up right now were part of the registration process. I think a follow-on question, which would be nice in this scenario here, why don't I just export my interfaces and connect them together outside of my system?
Question. So yeah, this is something I saw on a system design once, where somebody created a system design and they literally exported every single interface. Okay. Now, there's absolutely nothing stopping you from doing that, but it does require you to manually connect everything up in your HDL code outside of Platform Designer. The whole point of Platform Designer is to make these connections in the tool so that a custom interconnect is built for you to to build an optimized system design to allow components to communicate with each other. If you just export everything, then sure, you have all of the individual signals, but you're going to be writing your HDL code to manually instantiate and connect everything outside of the system, and it kind of defeats the purpose. So there's nothing stopping you, but it's not really something that people should or would be doing. Any other questions before I go into some new features?
Yeah, I guess once you go ahead and go into some new features, there are a couple more questions, but we'll hold off on those for right now.
Okay. All right. So yeah, folks, while I'm going through this, please feel free to ask any questions, put them in the chat, or ask over the phone. So let's see. Oops. Oh, I hate it when it does that. There we go. Okay. So new features. So like I said, almost every version of Quartus, we introduce some new platform designer features. Now, unfortunately, most of the time, those new features are only in the Pro edition. And there hasn't been a new version of the standard edition. The standard edition was updated last year. There's going to be an update to standard and pro with 22.1, which should be coming out any day now. But most of the new features usually end up in pro. So I'm going to highlight a couple of things that are kind of neat that were recently added in 22. Or late last year in pro edition. So the first is a diff tool. So it's very often the case that maybe you are, you're creating a new system design and, you want to build it off of an existing one, or you have some golden design that you have and you want to compare the design that you're working on with that golden design and see what the differences are. The system diff tool allows you to do just this. So this is what it looks like, but let me show you in Platform Designer itself. Oops, let me go over here. Okay, so here we are in Platform Designer, and I want to compare my system design with a different one. So as always in Platform Designer, every tool and feature is available under the View menu. So if I go into the View menu here, I go down to the System Diff tool and open that up, and I'm going to detach this to make it bigger. There we go. Oh, no, I want to detach it. There it is. Okay. Okay, so system diff tool. So you choose the two systems that you want to compare on each side. So on the left, as you can see, and let me bring it over a little bit more here, is the current system. And you can pick from a pick list of recently open systems or browse for some other system. And then on the right side, you can either stick with the current system, and I'll come back to why that would be in a moment, or pick another system to compare against. So the way it works, you turn on this option and you can see in color coding where there are differences. So if somebody could mute their microphone, unless you have is there a question? Okay. So these two systems very similar to each other, but the yellow indicates where things match up and other colors indicate where things are a little bit different. So in this particular example, I swapped out the clock source component over here on the previous system design for a separate clock bridge and reset bridge. So the systems are basically the same, and you can see all the yellow lining up. But there are some differences here. And for certain IP, this is not a great example, when you select something that has mismatching parameters between two similar components, and again, I don't have a good example down here. Oh, wait, let's see, did that? Okay, well, that's not a great example, but in any case, if there are if you have the same component in the two systems, but there are differences in the parameterization, you can quickly see what the values are for both the current system and the other system that you're comparing to, and then make adjustments if you need to have them match up or something. Okay. So the tool indicates in yellow if there are parameter differences, and purple and green if there are actual connection and placement component inclusion differences between the two. So you can choose exactly what you want to compare, and you can filter out what you want to focus on. So if I just care about components themselves, I can do that instead of looking at the individual interfaces that make up components. Okay. So kind of handy feature, making sure that things match up. There is, what I think would be the most useful is if we had a copy and paste feature, which unfortunately we don't. I don't know if that's something that might be coming, but we can at least compare between different system designs and make sure they match up, or if there are differences between them. So that is the first feature I wanted to highlight. Any questions coming in the chat, Steve, that or people want to talk on the phone and ask questions? They certainly can.
Yeah, no questions on the chat yet.
Okay. Excuse me. Well, then we'll continue on to another new feature that I wanted to highlight, is the Preserve for Debug feature. So Preserve for Debug is a way of doing just that. The idea is that maybe there are signals or interfaces or components in your system design that you want to use a debug tool for, such as the Signal Tap Logic Analyzer. One of the things that people have issues with is that through the compilation process, parts of your design might get optimized away. So if you have unconnected signals or other optimization settings in compiler settings in your project, parts of your design might get optimized away that you did not intend to get optimized away that you want to be able to analyze post-compilation. The Preserve for Debug feature guarantees that whatever you select to preserve will be preserved through the entire compilation process. So it's basically the equivalent of adding the 5 attributes shown here to a node or a logic in your design. So keep and preserve are the ones that folks are usually most familiar with to prevent optimization of registers and combinational logic. There's also no prune, preventing optimization of registers that have no fan out. Register merging if you have duplicated registers, and don't replicate to prevent register duplication. So basically keeping your design exactly the way that you've written it in your HDL. The idea here is they will survive basically through the compilation process, and then in tools like the Quartus in SignalTap, where you are adding signals to tap and analyze in the logic analyzer, there is a filter, a dedicated filter in the node finder to easily select those signals. Okay, the tool generates a report also of the nodes that were preserved, so you know exactly what has been preserved. It's important to note, of course, that when you're doing this, you're basically disabling optimization for parts of your design. So typically when you're done debugging your design, you're going to want to turn off this preservation so that your design can be optimized for perhaps a final compilation. The use of the tool is very simple in Platform Designer. It's simply a matter of right-clicking and selecting exactly what you want to preserve. You cannot preserve clock interfaces or entire subsystems. You can preserve other interfaces or parts of subsystems, but not the entirety of them. So again, I can show you this real quick, very easy to do. So this is actually where I got the screenshot. So I wanted to preserve this FIFO the way it was, and you simply select preserve for debug. I haven't compiled this design, but once you do compile the design, again, there will be a compilation report generated specifically indicating what nodes in your design have been preserved with the feature. And then if I Quartus here, where's Quartus? Here we go. And let's say I went into my SignalTap. So I'm here, and it's not going to show up again because I didn't compile. But if I were to add nodes here, we go to the node finder, you'll notice that we've got two new filters: pre-synthesis preserve for debug and post-fitting preserve for debug. So this makes it very, very easy to preserve nodes and make them accessible for tapping in a tool like SignalTap. So that's the second new feature I wanted to highlight. Right. Any questions coming in, Steve, or anything else you wanted to?
So another registration question that came in specifically about creating custom components inside of Platform Designer.
Okay.
I know it's kind of general, but maybe go over some of the features in Platform Designer to be able to do that.
Just creating them, or like
creating them. I think focusing around the generic component.
Generic components. Okay. So generic component. I'll go into generic components because that's something that confuses people as well. So in the Pro edition, so this is a Pro specific thing. In Standard, there's no such thing as a generic component. In the Standard edition, all components in your system design, go over to Standard here, must be complete and well defined. And what I mean by well defined is that you have HDL code for the component, and you've used the component editor tool, this is the component editor, to generate an hw.tcl or hardware.tcl script file that defines the properties of the component in the system. So the component editor is used to create custom components, but of course all the off-the-shelf IP that appears in the IP catalog that's included with Platform Designer are all complete and well-defined. They have HDL code, they have a hardware.tcl file that describes the parameters and other features of the component and how the component can connect to the rest of the system through the signals and interface settings. Okay. Now in the Pro edition, I'm going to close that, switch back over to Pro here. In the Pro edition, every component in the system is what's referred to as a generic component. So you notice if I go over the tooltip here for this component, it says generic component. Even the off-the-shelf stuff like this FIFO, notice that it says generic component. So all components in the Pro edition are generic by their nature, meaning that they can be at any stage of development, from an empty black box to a complete component. In order to define the properties of those components in Pro, it's done on a special tab called the Component Instantiation tab right here. And so for the FIFO, for example, if I drag this over, you can choose what the implementation is. So the FIFO is obviously an off-the-shelf component, so it's implemented as a full IP. But the key thing here is the fact that the parameters and definition of the component are in a .ip file. The .ip file in the Pro Edition is what defines all the parameterizations for each component, whether it's custom or off the shelf. It also is the .ip file also points to the HDL code that defines the component itself. So the .ip is really important and must be there. You can even choose a different .ip, maybe from a different project, and you can re-add or add copies. Might go down far enough here. We got lots of them here. You can add new components based off of .ip. So the .ip represents a particular parameterization of a particular component. If I added one of these to my system, well, these are already components that have been added into the system, and so that's kind of the closest you get to a copy and paste, being able to add another copy, another instance of the same parameterized IP. Now, it's kind of a roundabout way to get back to generic components. But like I said, everything is a generic component, but they get defined with .ip files. But you can create new components in the Pro Edition as generic components. So I could, from the IP catalog here, create a new generic component. And instead of the usual parameter editor that appears, you'll notice that the Component Instantiation tab appeared. Okay. So all components start out as black boxes, empty components that I can fill in. Okay. You'll notice that there's no option to select a .ip file here because there is no .ip file for a black box. A black box is just that. It is empty. So what I can do is start building my component based off of the signals and interfaces, what we call the component footprint, how we want to connect the component to the rest of the system. So I can manually add interfaces and signals here, or I can import interfaces from a separate, from an existing .ip file, or we also support IPExact, which is an industry standard for IP distribution. So you could select that, and that will define all of the signals and interfaces. And again, at this point, there's no HDL code. At some point, and you could still add this component to your system and generate the system. It's just basically leaving a hole in your system design until you fill it in. When you're ready to fill it in, you can switch the instantiation, the implementation from black box to either HDL or IP. The HDL implementation is similar to black box. Notice there's no .ip file yet, but you point to the HDL code that has been created for the component. And when the system gets generated, this type of component gets implemented as part of the interconnect itself. It doesn't have a separate .ip, so it's built into the interconnect. So it's not really portable. It becomes part of the system. What you eventually want to do is turn it into a full IP. And that means switching it over to the IP implementation type and finishing it to generate a .ip file. Okay? And then that is a full IP component that can be added into any design, just like if you use the component editor. Okay? So generic components. All components in Pro are generic until they're not, essentially, until you fill them in.
All right, thank you, Steve. Another question. This individual has never had to worry about it. He understands that Platform Designer does handle clock domain crossing scenarios. But this individual is curious, what exactly does Platform Designer do to manage the CDC scenarios? You know, where you got different clocks inside your Platform Designer system.
Let's see. So, okay. Um, well, there's a few things. Okay. So yes, you can. There's a few things that you can do. You can either let Platform Designer handle it all for you, or do it manually. Let's start with the automatic. So the easiest way to look at this, let me move this over here, is look at the clock domains in a design. So I'm going to go to the View menu here and open up the Clock Domains tab. And this is a very simple design clock domain wise. There's really only two. So I can click on a clock domain to filter my system view into different colors, the colors referring to the different clock domains. So I've just got the clock that's coming in to the system, going to this PLL, and then I have the output clock of the PLL that feeds everything else in my system. Now, as far as clock domain crossings are concerned, the easiest way to see what the tool is doing is when you go into this filtering, and another way to get into that filtering is from this button down here, is the little red dots. So the red dots indicate where adapters are going to get added into your system design. Okay. Um, Unfortunately, this example, does it have an option? No, unfortunately, this design does not have a clock domain crossing that I can show you. But if it did, there would be a red dot between the two interfaces that were in, say, two different clock domains. And the tooltip would indicate that there was a difference, what the difference is, and what the tool is doing. So at the bottom, it would say a clock crossing adapter is being included. Now, you have some control over how the CDC logic is implemented, and I'll show you that over here. This is in the Pro Edition. I'll show what it is in the Standard Edition in a moment. And this filtering is in the Standard Edition as well, so this is both Standard and Pro. But for Pro, to adjust how clock domain crossings are handled, you go into the Domains tab, you select a host interface, and then down below we have clock crossing adapter type. Okay, and you can choose a handshaking mechanism, a FIFO, or let the tool automatically add clock crossing logic for you. Okay, and you can do that for each memory map domain in your system design. In the Standard Edition, it's not that localized. It's going to be just a global setting. So you go to the interconnect requirements, and at the top you have clock crossing adapter type. And so it's handshake, FIFO, or auto. Okay. So that is how we handle going between different clock domains automatically. There are also, let me turn off this filtering here. There are also components that you can manually add into your system design to handle clock crossing. So let's see. Yeah. So there is a clock crossing bridge, and I can open that up real quick. And so you can see what this does. So we've got a clock coming in on one side, a clock coming out on the other side, and you have options for how you want to implement going between different clock domains. So you have more fine-grained, fine-grained custom control of how the clock crossing is implemented, as opposed to letting the tool just do it for you automatically. Answer the question. Is there more to it there, Steve, or anything else?
No, there wasn't any follow on with that.
Okay.
Question did come in on the chat window. In Standard Edition, is it possible to import a component from the hardware.tcl?
Import a component from hardware.tcl.
No.
Not entirely understanding the question.
So maybe maybe there's a hardware.tcl file that already exists. Can you use that hardware.tcl file to bring in a component into your system?
Well, if there's associated code as well, I don't know if that's what's being implied with the question. But if you have your HDL code and you have a hardware.tcl, then as long as Platform Designer can see the location of the hardware.tcl, it's in the IP search path or it's in the project directory, then the component will appear in the IP catalog. So I'm not sure if that's what the question is asking, but yeah, as long as it's a valid hardware.tcl and you've got the HDL code making it a complete component and Platform Designer can see it, then yes, that would be able to be used in your Platform Designer system.
Yeah, I think you got the gist of the question that they were after. That looks good. Okay, so another question here. Can you elaborate on HLS for Intel FPGAs? So let's rein that back in the context of Platform Designer. And so I'm gonna rephrase the question. Say, can you use HLS for Platform Designer?
Can't show it because I'm on Windows right now. If I was on Linux, the component instantiation tab here would have one extra option specifically for HLS. So with that extra option, you can do your HLS compilation for your component when you bring in your HLS code when creating a new component as a generic component. So that's in the Pro Edition, so it is there. Again, I'm not an HLS expert, but yes, you can certainly do that, and the compilation for that code will happen when the system gets generated.
All right, so it sounds like that instead of having HDL code for your generic component, you can have HLS, well, C code, and HLS will just handle all that. Okay, good. Okay, so follow-on question: how efficient is the HLS implementation compared to RTL? So slightly off topic, Steve, but I don't know, maybe you want to touch on that just a little bit. Question is, how efficient is the HLS implementation compared to RTL? Steve, I think we've lost audio from you.
Oh, you don't hear me?
Okay, yeah, I can hear you now. Yeah.
You hear me? Oh, I'm sorry. How long was I out?
Well, after I asked the question, I couldn't hear anything.
Oh gosh. Okay. So what I was saying is that I'm not an HLS expert at all. So I would not be the right person to ask that question. I don't know about efficiencies in writing HLS versus RTL code. So I'd be the wrong person to ask about that. Sorry.
Okay.
Hi, Stephen.
Yep.
Stephen.
Hello.
I'm Duncan, the product marketing manager actually for HLS.
Oh, great. You are
that,
perfect for answering this, Duncan.
Yeah, the HLS results shouldn't vary that much from the RTL, but plus or minus 5 or 10%. So it really depends on what you're focusing on and how you would set your directives. But just straight out the box, you should be looking for very similar results. Okay.
Thank you so much.
No problem.
Steve.
Thank you.
Sure. Steve, anything else coming up?
Yes. So a follow-on question, talking specifically about how you mentioned about you had someone exporting all their interfaces into Quartus. Apparently a follow-on question is, I guess there's a need from time to time to be able to export your interfaces from Platform Designer to interact whatever you need to inside of Quartus. What's the best way of doing that?
Best way of exporting?
Exporting interface. So let's say I'm just going to fill in the blanks here. Let's say it's it's one of the standard interfaces like Avalon or AXI.
Okay. Well, there's really not much to it. It's just a matter of saying that you want it to be exported. So you type in a name in the like it says, double click to export. Type in a name, and then when you generate the system, it will generate those signals as ports for the system design, and you can see those ports in the instantiation template. So you can see a listing of all of my exported interfaces here, and then how I would connect this to the rest of my Quartus project, and either Verilog or VHDL. So I don't know if I'm really answering the question, because maybe I'm not understanding the question.
No, I think you answered the question well with that. Thank you.
It's really easy to export.
Okay, perfect. Let's see here. Looking through some of the registration questions here. Oh, okay. Here's one. The are there examples where there could be a data width mismatch inside a platform designer? Like how do you match up data the data buses?
So again, that's another one of the advantages of connecting things directly in Platform Designer. The tool handles it all automatically when it generates the system. So you can have 8-bit components, 16-bit components, 32-bit components, and excuse me, and everything will get adapters automatically get added to the interconnect logic for you to handle that. The tool will show you again with these red dots when you turn on filtering where adapters were added. So for example, here an Avalon adapter was added in. In this case, it's pretty standard difference that there's the addressing is a little bit different on one side or the other. But again, the tool does that all for you automatically. If you want to dive into and understand what the adapters are, you can certainly do that. There's a number of ways of seeing the logic. So for example, I could go to, where is it? System, show system with Platform Designer Interconnect here. And I can view the logic implementation in a sort of schematic view of what's getting put into the interconnect. Just to chug a little bit here to generate that. La-di-da, hopefully done shortly. There it goes. Okay, and so there's, this is a much more detailed view of essentially the internals of all the components and the interconnect. And I can look at this in a schematic view as well, where logic gets inserted into the interconnect. So you would see adapters in here if there were any added things like that. So I guess that's the answer. I'm not sure if people were looking for more than that.
No, I think that's good.
Okay.
Another question. I think this one's relatively straightforward. I'm and at least I'm more of the feature as well. Pipelining the interconnect that exists inside of Platform Designer. Where can I find that feature?
So so one of the things that you might find when you're building a large, complicated system design is that you might want to optimize it for performance. There are a number of ways of optimizing a system. I have a whole online, one of those 4 advanced online trainings that I mentioned earlier goes into system optimization. One of the main ways to optimize a system design, of course, is to insert pipeline stages. And there's a number of different ways of doing it. The first immediate way to do it is have it done for you automatically. So in the Pro Edition, and I'll show again what it looks like in the Standard Edition in a moment. Again, if you go into the Domains tab here, you can select a memory map domain. And then down below here, you can choose the option Limit Interconnect Pipeline Stages, okay? And you can set that up to 4. So what that means is you're saying, okay, when you build the system, you can add up to the number that I select here of pipeline stages in order to optimize for performance. Okay, it may not go up to 4. It may use 1, 2, or 3, but you're saying that it is free to add that many extra cycles of latency in the interconnect in order to optimize the performance. Okay. There's also a shortcut here, enable all pipeline stages, which forces it to always enable all of them. That might be overkill, but the option is there. Okay. So that's the most immediate way to do it. In standard, in standard, the option is right at the top, limit interconnect pipeline stages to. Okay. In standard, you can't force it like you can in Pro to use all of them. And so these are both in standard and Pro, they're in very specific locations in the interconnect where they will get enabled. The second way that you can add pipeline stages is in this same interconnect view that I talked about. So you'll notice these registers here, those are the ones that are added with the feature that I just talked about. So these were automatically added pipeline stages, and it shows you them right there as part of the MUX logic in the interconnect. But I can also enable additional pipeline stages beyond the automatically added ones if I need the performance optimization by turning on show pipelinable locations here. And you'll see there's a number of little gray register locations that I can add in, and then I can right click those and enable them. You have to be careful of these though, because obviously you're adding cycles of latency on individual paths, and you might need to match up the timing, the number of cycles on other paths when you do that. So you have to be a little careful with that option, but that is also a possibility. The final way of adding pipelining is by adding components into the system design through the use of pipeline bridges. So if I go into here, so there are pipeline stages available for streaming interfaces, but I usually focus on the memory mapped ones. And if I open up the pipeline bridge parameter editor, you can see on one side it has an agent interface, on the other side it has a host interface, and I can choose options for going through the pipeline bridge, the data widths and such, and I can choose to pipeline just the command signals or just the response signals. I could turn those off, both of them off, and basically turning the pipeline bridge into just wires. And I might want to do that if I wanted to simply adjust the topology of my system without adding extra cycles of latency. Okay. So you can do that and choose options for how many stages you want to add in for a particular pipeline bridge. So lots of different options for pipelining and optimizing the performance of a system. My online training goes into more detail on the use of this. So.
And a follow-on question for myself: how do all these features fare with targeting HyperFlex architecture like Stratix 10 and Agilex? When you have your platform designer system inside there, when Chorus takes the design and runs with it, how well does these features in platform designer mesh with the HyperFlex features?
That's a good question. So I forget right now if platform designer is truly taking advantage of HyperFlex yet. So for those who aren't familiar with it, just to briefly explain what HyperFlex is, in our Stratix 10 and Agilex devices, they have this HyperFlex architecture, we call it. And that means that there are hundreds, thousands really, of small, simple registers sprinkled throughout the interconnect fabric of the FPGA. And also they're available on all the inputs of block resources. So there's a register available at every vertical and horizontal wire crossing in the fabric, as well as at the input of every memory, every ALM, everything. The idea being is that you can create a heavily pipeline design, allowing you to run your design much, much faster. And what the compiler does is it takes registers from your FPGA design and moves them from the standard ALM lab locations, the logic array blocks, and moves them into these HyperFlex registers to better balance out delays between registers, optimizing performance. Now, last I checked, registers added or that are part of Platform Designer, I don't believe are retimed into those hyper register locations. I don't know if that's changed, but I don't think they do. to be honest, I'm not 100% on that one, because it's, for a long period of time, it did not take advantage of HyperFlex. Then maybe it did at some point, and maybe I'm not remembering that it did. But you stumped me, Steve. I think I need to look that one up.
Okay, sorry about that. Yeah, I do remember reading some features. I think it's about a year and a half ago that Platform Designer was retooled. You know, to use a generic term there to take advantage of some of the HyperFlex registers. I just didn't know how widespread that was.
Yeah, I think it might. Now let me think about that a little bit more. So yeah, there is options to support that. So for example, there's this use synchronous reset option here, and that was added specifically because in HyperFlex devices, the hyper registers do not have asynchronous reset control. So you want to make sure that you always use synchronous. So that's set to true by default in a HyperFlex device. So maybe you are correct. I think maybe you are correct that it is now taking advantage of HyperFlex and those hyper registers.
Right. Thanks, Steve.
Sure.
We do have a question on the chat window. I'll just read it here verbatim. Do you have any example with 100 gigabit Ethernet core implemented into Platform Designer? And to continue the question, if we need to implement, for example, 4 times, 4 of these 100 gigabit Ethernet ports plus a PCI core, is a Platform Designer good enough option to be able to manage a scenario like this?
Absolutely. It's probably the easiest way to actually do it. So you just search for PCIe, for example, and add the IP in, very similar to what you would do with manual instantiation in Quartus, and automatically be able to create the connections and hook everything together. So yeah, most of the IP that's available in the main Quartus IP catalog is also available with an Avalon or AXI wrapper available in the Platform Designer IP catalog. So there's no reason not to use Platform Designer for designs like that, if that's what the question is really trying to get to.
Yeah, I think so. If I were to kind of read between the lines, they're probably hoping that Platform Designer would be able to would be a good tool to be able to manage cores like this. I think what sounds intimidating is that we've got 100 gigabit Ethernet cores, but Platform Designer really shines in how easy it is to connect interfaces together. You just drop the core in there regardless of how fast they are and connect the interfaces up. And so that's I think Platform Designer does an excellent job with that.
Yeah, it's so much easier.
Yeah. Okay, let's see. We don't have any more questions from the chat window, and the pre-session questions are all out as well. If anyone can think of any last minute questions, throw Steve's way. We do have officially have 5 minutes left in the Ask an Expert session.
Okay. Well, for those last 5 minutes, then Steve, while unless something pops up in the chat, maybe you want to put the survey and the links in the chat at this time.
Yes.
And I can just talk for a couple minutes about some other stuff, just real briefly, unless some other questions come up. Let's see, what else could I highlight for folks? I already talked about in Pro this feature, so about the .ip variants that are available, which is kind of neat. Let's see, what else could I show you real quick here? I talked about Preserve for debug. I talked about this at the, well, a couple of things. One, like I said, I am having, I believe, I'm teaching the Platform Designer class. I believe I have a session next week. So if that's something that you're interested in, all of our instructor-led training classes are free. They are 4.5 hours across they're a full 8-hour class, but 4.5 hours across 2 days. So please feel free to register for that. I will be teaching that pretty shortly. If not next week, then later in April, I believe. And again, we have these sessions every month as well about different topics. But one other feature that I highlighted in the previous Platform Designer Platform Designer Ask an Expert session was the HDL parameters feature. So this was added just last year. And this is a way of handling parameterization of components in a hierarchical system design. So just like in a standard FPGA design in Quartus, you have a project hierarchy, and you can set parameter values that then get passed down to lower level components. You can do the same type of thing in a hierarchical system design. So I have components that have parameter values here in my top level system. I can also very quickly, because I know we're almost out of time here, I'm going to dive into a subsystem here, and you can see all the components that have parameter values in this lower level system. And I could say export this particular interface, or sorry, this parameter. Okay, so now when I go to the top level system, that one becomes visible if I can find it here. That wasn't the best example. Oh, there it is. Okay, so it shows up here, and then if I turn on the export option and I go back to my top level system here, then you'll notice that I can set this lower level parameter to its own custom value. So I could type in a value here, or I could export it again if I had another higher level to bring it up. So you can bring parameters through different hierarchical levels in your hierarchical system design. So that was a new feature that was added late last year as well. So.
One last question. It looks like there's interest in your upcoming class. Question is, do we need the appropriate hardware to attend the course?
No, that's one of the great things about our training classes. You will be connecting to a remote desktop computer that is fully configured with Quartus and Platform Designer. And that also includes the ability to connect to a Stratix 10 development kit, and you'll be able to work with that kit through a special graphical interface that we've set up. So it'll be like you're sitting in front of it, being able to push the buttons, look at the LEDs, etc. So you don't need to bring any hardware other than your computer. And on that, I guess we're done, right, Steve?
Yep, I don't see any other questions coming in.
Okay. You want to finish us off here?
Yes, sorry, excuse me about that. Yes, okay, so thanks everyone for attending. Hopefully you've had some questions answered. And this, like I mentioned, this session is recorded. So if you want to send it off to a colleague or something like that, the session will be recorded. There'll be, if I remember correctly, there'll be a link where the recorded session will be in a follow-up email. I did put the links to the resources in the chat window, so check those out. There is also a link to a Qualtrics survey. If you wouldn't mind clicking on that, filling out that survey, that'd be fantastic. We do want to know what went well and what we could improve on. It's always helpful. Let's see, and then with this, that is the end of the session. I'll go ahead and stop the recording now, and that's that. Thank you everyone for attending.
Stop, Steve?
Sorry.